Hello everyone, this is Dharmendra Reddy MS, pursuing education in Sri Venkateswara College of Engineering in Department of Computer Science and Artificial Intelligence. Now let's know about Quicksort. How Quicksort works. Divide and conquer. Quicksort power emanates from its divide and conquer technique, which recursively sorts subarrays of given array. Sorting sequence. Sorting sequence. The sorting sequence starts with a pivot element selection, followed by rearranging all elements smaller to the left and larger ones to the right. Recursive function cells quicksort's extension is based on the recursive function. Let's see the implementation of quicksort algorithm. Selecting pivot element. The pivot element selection is the principal step of the quicksort algorithm implementation. It might be chosen in numerous ways. However, most applications choose the first or last element in the array. Partitioning. The partitioning process is the most critical and challenging stage of Quicksort. It involves partitioning the array with respect to the pivot and putting smaller values to the left and larger values to the right of the pivot. Now recursion. Upon executing partitioning, we take each subarray resulting from partitioning process and apply the same sorting algorithm recursively. Termination. The end of the array and any given partition occurs when the subarray size equal 1. Discuss about algorithm for quicksort. Now let's see algorithm of quicksort. Quicksort of A into L so on R, and we are using if condition if L is lesser than R. Partition of A into L so on R is S, and quicksort of A into L so on S minus 1, and quicksort of A into S plus 1 so on R. And now let's see partition of quicksort. Partition of A into L so on R. A of L is pivot, L plus 1 is I, R is J. Repeat. Repeat I plus 1 is I until A of I is greater than or equals to P. Repeat J plus 1 is J until A of J is less than or equals to P. Swap A of I, A of J until I is greater than or equals to J. Repeat the condition, swap A of I, A of J, and swap A of I, A of J, return J. See, time complexity analysis of Quicksort algorithm. Gamma of n log n. In best case scenario, Quicksorts the array with the time complexity of gamma n log n. Average case, theta n log n. On average Quicksort, an array with theta n log n time complexity. It is a reasonable time complexity, providing Quicksort with unmatched efficiency. Worst case, big O of n square. Worst case involves sorting a nearly sorted array with time complexity of n square, since worst case scenario strikes the partitioning the array. Now let's see how to pick the pivot element. The pivot element can have a huge impact on performance. That's why one needs to be selected carefully. There are several techniques to choose a pivot element, including 1. First or last element. Select the first or last element in the array as a pivot element. 2. Random element. Randomly select an element from the array as the pivot element. 3. Median of 3. Choose the median value from the first, middle, or last elements in the array as the pivot element. Now let's solve a problem using Quicksort. Now I'm going to take the values of 5, 3, 1, 9, 8, 2, 4, and 7. Now let's take 5 as a pivot element. Now let's take 3 as I, but according to condition, I should be greater than pivot element. And here 3 is lesser than 5, so we can't take 3 as I element. And now we're taking I1 as I element, and 1 is also lesser than 5, so we can't take 1 also as I element. Now we are taking 9 as I element, and 9 is greater than 5, and it is satisfying the condition of I should be greater than P. Now let's take J as 7. There is one more condition as J should be smaller than P, and 7 is greater than pivot element, so we can't take 7 as J element. Now we are taking 4 as J, and it satisfies condition as J should be smaller than pivot element, and 4 is smaller than 5. Now we have to swap I and J elements. Swapping 4 is I and 9 is J, and it is not satisfying our conditions because 4 is smaller than 5 and we can't take I as 4, and we'll move forward. Now we are taking 8 as I element, and it satisfies the condition as I should be greater than P. But J element is not satisfying element because J is greater than P, but it should be J is lesser than P. So we'll move forward. And now we are taking J as 2, and it's satisfying the condition, and 2 is lesser than 5, and we are swapping both I and J. After swapping, 2 is I and 8 is J, and now it's not satisfying the conditions, so I should move forward, and I comes to the place of J and J comes to the place of 2. And once I overcomes the J element should be swapped with pivot element. Once pivot element is swapped with J element, 5 came to the place of 2 and 2 came to the place of 5. Now 5 came to its position, and we got two half arrays as first half is 2, 3, 1, 4 sub array, and second half is 8, 9, 7 sub array. Now let's sort first half. Now let's take 2 as pivot element and I as 3, and it satisfies the condition. And let's take 4 as J element, and it is also not satisfying the condition. So we are taking 1 as J, and it is satisfying the condition. Now we have to swap I and J. After swapping I and J, 3 came to 1 place and 1 came to 3 place. And I is not satisfying in the condition. So I moves forward and goes near J, and J moves forward and comes near Y. Once J overtakes the I element, it should be swapped with pivot element, and now we have to swap 2 and 1. After swapping, we have successfully sorted first half of the subarray. Now we will sort the second half, and we are taking 8 as the pivot element, 9 as the I element, and it satisfies the condition, and J as the 7 element, and it is also satisfying the condition, and we are going to swap I and J. Now 9 came to 7 place and 7 came to 9 place. And now I is not satisfying the condition with P out. And now we have to move I forward and J also forward. And now both J and I move forward. Once I overcomes the J, we have to swap J and pivot element. So we have to swap 7 and 8 element. After swapping 7 and 8 element, the entire array has been successfully sorted. Now let's see advantages and disadvantages. Advan Now first let's see advantages. High efficiency, flexible in large data sets, good for parallelization, easy to implement and understand. And now let's see disadvantages. Not suitable for small datasets, not stable, performance can greatly suffer in the worst case scenario, requires extra memory space. Now we will see real-time applications of Quicksort. Generally we use in libraries. Quicksort is used to standard library algorithms in many programming languages. Optimizing function calls. Quicksort is used in optimizing function calls in many languages such as JavaScript's weight engine. And now disk space management. Quicksort is used in managing disk space as it allows sorting of files according to memory size and its type. Conclusion. Quicksort algorithm has demonstrated to be an effective tool for sorting algorithms that can tackle large datasets and parallelization. Its performance can be highly optimized with careful pivot element selection, which can reduce the occurrence of the worst case scenario. Nevertheless, it's important to acknowledge the limitations and drawbacks before implementing it in any particular applications. Thank you.